All right, so last section we are going to take a look at is part of 1.3. We're not going to finish the whole thing. We'll end up finishing it next time. And this is on functions. Now, by the end, you'll hopefully either remember, if you never learned it, but you probably did at some point. At least you'll know it after this class. But not everything you draw on the calculator is a function. There's lots of pictures you can draw that are not functions. To be a function, it has to pass a certain line test. Does anybody remember the name of that test that a graph has to pass in order to be a function? So something line test. No one remembers that. Yeah.
Linear line test or something like that. Is it like when they have the straight line and it has to go through? If it's like a parabola and touches 2 points on the line, it's wrong. It's not a function.
All right, so it does have to do with drawing a certain kind of line, and if it touches the graph more than once, it's not a function. Does anybody remember what kind of line, though? No? Yep.
Is it a vertical line?
Yeah, the vertical line test. So if you draw a vertical line and it hits the graph more than once, it's not a function. Okay, so we'll talk about that, but I'm going to start out with something a little different. Okay, so we did this yesterday, the rent-a-car problem. We had the equation y equals 0.2x plus 15. And we talked about different, well, actually we only talked about one name for the x and the y. They weren't the names that I have up there right now. Does anybody remember the name we gave to the x? Yep.
No, yeah, independent variable.
Independent variable. And the name we gave to the y?
Dependent variable.
Dependent variable. Yep. Well, besides those two names, there's other names. You can also call the x the value you are plugging in. Right? So we call it the input. And the y is the answer that you get from the formula. Okay, that's called the output. In this case, the formula takes the input value, multiplies it by 0.2, and adds 15. And after you multiply by 0.2 and add 15, that answer that you get is the output. You can also call x the domain, and y you can call the range. And a lot of times when we are looking at a function, they're going to ask us to figure out what is the domain or what is the range of the function. When we are looking at domain, there's two things we have to be careful about, okay, that we're not allowed to do. Does anybody remember one thing you can't do with division? You're not allowed to do this. Something with division. Yeah?
Divide by 0.
Right, you can't divide by 0. So if you had a problem like this, and I asked you, what numbers are you allowed to fill in for the x? You can fill in any number you want except one number. There's one number you can't plug in for x there, because if you did, you would be dividing by 0. What number are you not allowed to plug in for x there? Yeah? 2, yeah. So if you were asked for the domain of that function, it's every number except 2. So that's one type of problem that you have to be careful about domain. You never want to plug in a number that causes you to divide by 0. Okay? And there's one other one. Square roots. If I ask you for the domain of a function like that, we want to make sure that we never take the square root of a negative number. Okay? If we do, it's going to be imaginary. Right now, we don't want that. So if I never want this to be negative, that means I want it to be 0 or up. What numbers could you fill in for x so that you never get a negative under the square root? Yeah?
0 or higher?
Well, if you plugged in -1, what's -1 plus 3?
2.
2. So actually plugging in -1 for x is okay in this problem because you're going to add 3 to it. So that gets rid of the negative. Yeah.
You run anything over -3.
Anything, can you say that again?
Anything that's greater than -3.
It's greater than or equal. Yeah. 0 is okay, but you don't want it to be negative. So the domain of this function is anything -3 and up. Okay. You can't go lower than -3. Right, but those are really the only 2 things that we have to be careful about when we're finding domain. Do you have a square root in your problem? Okay, if you do, we have to be careful. Or do you have a fraction with a letter in the bottom? We have to be careful with that too. But that's pretty much it. A problem like this, technically you could say the domain is all real numbers. There's no square root here, and there's no fraction with a letter in the bottom. Now, practically though, x was mileage. So in terms of the word problem, what numbers would make sense for x? Even though mathematically you can fill in any number you want for x, in real life certain numbers don't make sense. Yeah?
Positive numbers.
Positive or
What were you asking?
what else besides positives? 0. 0. So you can plug in any number here practically that's 0 or higher. Even though algebraically a negative number will give you an answer, it wouldn't make sense in the word problem. Okay, that's different when you're doing word problems. Okay, so what makes something a function? That's the definition of a function. When you plug in a number for x, you get exactly one answer for y. So let's say we were making a table for this one. Okay. Y equals 3x. If I plug in 1 for x, what do I get for y? Yep, 3. Do I get any other answer? No. Because the formula says take the x value, triple it, and you get the y. You will, if you plug in 1 for the input, you will only get one answer for the output. In this case, the answer is 3. What if you plug in 5 for x?
15.
You'll get 15. There is no other answer you will get. Okay? So something like this is a function. Okay? That's good. Okay. Here's something that's not a function. If I plug in, let's say 4 for x, what's the positive square root of 4? Yep.
4. 2.
2.
Sorry.
Yep, 2. And what other number times itself also gives you 4?
-2.
-2. So the problem here is you plugged in one number for x, and you got 2 different outputs. You didn't get one output. That would fail the vertical line test, which means it's not a function. So that's not a function. Okay, not a function. And this one was a function. Kind of already said that to you, more or less words. So again, domain, that's what you are allowed to plug in. Range, that's the answer you get back. I wrote the word valid there. That just means don't plug in a number that would cause you to divide by 0. And don't plug in a number that would cause you to take the square root of a negative. If you plug in a number that causes you to divide by 0, that's an invalid input. That's not good. We don't want that. So the kinds of numbers that we are working with are real numbers. Okay. What are the other kind of numbers you learned about in Algebra 2 that are not real? Yeah?
Imaginary.
Imaginary. Okay, that's a whole other thing that we're not doing right now.
Thank goodness.
We will though.
Those.
Okay. But for now, we're working in the real number system. Now, when you write down a function, there are two different ways you can do it. This is the notation I've been using so far. Y equals, and then the formula. Well, the other notation, it doesn't change the right-hand side. The right-hand side is still a formula that looks like that. But you can put something different instead of y. Does anybody know words?
F of x.
Right, you can write f of x. And that's called function notation. So what this technically means is f is the name I've given to the formula. This is formula f. Of x means the formula uses the letter x. So if I wrote something like g of x, just make up something different, that means I've given the name g to that formula, and the letter that it uses is x. So, name of the formula, variable in the formula, specifically the independent variable. And it might not always be x. You could write like a formula h of k. Maybe this represents the height of a kite. So you wanted to use k to represent height. So you got some formula that calculates how high the kite is going to go. All right, so now let's try to find a complete graph of that. Okay, what does that mean I need to write down when they ask me to find a complete graph?
The window.
The window. I'm not sketching the graph, I'm writing the window. Okay. So let's go to y equals. Put in the square root of x minus 3. And what's a good window to always start out with?
Standard.
Yeah. So how do we do a standard window?
Zoom 6.
Zoom 6. Now remember, this is a square root. It should look like a parabola on its side. Well, half of a parabola. Okay. So what do we think? Is that a good window? Boris, what do you think?
I think we can make it a little bit bigger.
A little bit bigger? Okay, so which number do you want to make bigger?
The x max.
X max, and how much bigger do you want to make it?
20, 25.
Like 20 or 25. Right, so now we can see a little bit more of it. But yeah, that window, even the window we had before was okay. With a square root function, you want to be able to see where it starts. And then you want to see it being able to curve. If you had a window like this, there's no question that's not a good window. Okay? I mean, I can kind of see a little bit of a curve, but I can't actually see where it's starting. And I should be able to see that. Okay, so that's a good one. All right, now, we're going to use that and try to figure out the domain and the range. Okay. Does this function have anything in it that I said you need to be careful about when you're finding domain? Yeah?
Square root.
It has the square root. So the domain, you got to think about. What numbers would you be allowed to plug in for x? Yeah, Julia? Right, the domain would be all numbers 3 and above. If you plug in a number smaller, like 1, well, that's a problem. 1 minus 3 is -2. Can't do that. So domain we can usually figure out just by looking at the graph. I mean, looking at the equation. Range, we usually do that looking at the graph. Okay. I didn't write the window down yet. I'll do that in a second. So range is how high and low the graph goes. Okay. Domain tells me it goes from 3 to the right forever. But now range is up and down. How low does the graph go? And it doesn't go any lower than this number, up to down.
0.
Yeah, it doesn't go any lower than 0. And how high is the graph going to go? Yep.
Always. Infinity.
Infinity, yeah. This just keeps going. Remember, if it's a parabola, it's just going to keep getting wider and wider, even though it's only half a parabola. It's still getting wider and wider. So the range is every number from 0, and the graph is going to continue up forever. And that's how you would write the range. Yep.
How would you know it's 0?
Well, one way I know it's 0 is if I look at my domain and I plug in 3. What's 3 minus 3? And what's the square root of 0? 0. So I know if I was making a table of points for this picture, if you plug in 3, you get 0. So I know it hits 0. Yeah. Sometimes it might not look like it hits 0. It might look like there's a little bit of a gap there. The calculator can't always draw things perfect. Right. All right, let's try this one. Find the domain and the range. Oh, I still didn't write the window down for the last problem. So the window was -10 to 20 and -10 to 10. Yes. So -10 to 20 and -10 to 10. Remember, the numbers are always in order: x min, x max, y min, y max. If you don't want to do it that way, you can write out x min, x max. That's a little faster. Okay, let's look at this one. X squared minus 4. Okay. Does that formula have one of the two things in it that I said you need to be careful about when you're finding domain? What do you think, Jack?
No.
No. It doesn't have any square roots in it. It doesn't have any fractions with a letter in the bottom. So the two issues that would cause a problem are not there. So what do you think the domain is? Yeah.
All real numbers.
All real numbers. You can take any number you want in math and raise it to the second power. That's never an issue. Anything. Positives, negatives, fractions, decimals, pi, okay, any number. So the domain, again, we can get that by looking at the picture. But range, that's a little bit harder. We're going to graph that. Yep.
When that's an answer, do you want us to write all real numbers, or can we do abbreviation of ARN?
Eventually, we're going to be doing something like this. That's what I want you to write eventually. This means the lowest value you can pick is -infinity. The highest value you can pick is +infinity. And the parenthesis means you can't actually reach it. Okay? This is called set notation. We haven't quite gotten there yet, but that's eventually what I would like you to write. Yes?
So we can't do the weird R for our real numbers. You want us to do it?
You could, for now, you could abbreviate that the way you just said. You could.
Well, no,
Yeah.
the weird.
Yeah, the R symbol. Yeah, you could use that symbol for now. just that's not a symbol that every computer has on it easily. So like in pair assessment, I don't think they have that R symbol that I can have you do, but they do have the parenthesis symbol and an infinity symbol. So those are more common symbols. Yeah, I don't even know if you can do something like that. Like if you're in Google Docs, I'm not sure how you get that symbol. I mean, you could import it as an image, but I don't know if you can type it like on the keyboard somehow. All right, so let's look at the range. So x squared minus 4. Okay, so let's type in x squared minus 4. Again, we'll do zoom 6 just to reset it. And do you think that's a good window?
Yep.
Yeah, it's perfect. It's supposed to be a parabola. I can see the whole parabola. And what's important is I can see the bottom of it. Okay, so domain, all real numbers. That means this graph is going to go left and right forever. And that's what happens with a parabola. It just gets wider. Does this graph go up forever? Okay. Does it go down forever? Okay. Then the range is not all real numbers because it doesn't go up and down forever. What's the lowest that it looks like the graph goes? Yeah.
-4.
-4. So the range is always your y variable, is every number from -4 and up. Okay, that's your range. Any question on that? Now, have we talked about how to type absolute value in on the calculator? Nope. Okay. So let's take the same graph we just had, except put it in absolute values. So remember, absolute value makes it so the y value is never negative. So when we do this graph as an absolute value, anywhere that the y value was a negative, it's basically going to make it positive. Let's type that in. So to do absolute value, press math. Press the right arrow to go to number. And then the first option is ABS. That's absolute value. Once you hit that, you should get the two vertical bars. And now you can put x squared minus 4. You're going to stay inside the absolute values if you keep typing numbers. But if there was something on the outside you had to type, you can press the right arrow, and it would move you outside the bar. If you want to go back inside, press the left arrow. Okay, so let's take that. Hit graph. And that's what our graph looks like this time. So remember, this part before was down here.
It's a fish.
But absolute value flips it up. Okay, what between domain and range, what didn't change between this graph and that graph?
The domain.
Something didn't change at all. Yep, again.
It still goes up infinitely.
So
The domain.
the domain, yes. The domain is exactly the same. But the range is not. What is the range now? Yep, Katie?
Greater than or equal to 0?
Right, it doesn't go any lower than 0. That's the lowest, but it goes up forever. Okay, so the point of that one was really just to show you where the absolute value button is on the calculator. It's math, number, and then it's the first option never. Now, if you forget, you're like, I don't remember where absolute value is, or if you forget where anything is, there is a catalog on the calculator of every formula in alphabetical order. So if you press, go back to the main screen, if you press second and you press 0, you'll get a list of everything the calculator does in alphabetical order. So there's probably hundreds of things in this list. Right, so you can see all the different things. And absolute value just happens to be the first one. Which button? If you press second and then you press 0. Now, let's say you knew you wanted a function that began with an m, but you couldn't remember it. Well, it's going to take you a long time to get to m.
Oh my goodness.
But if you see all these green letters
Oh, close to it.
here, I think you can press the button right below the green letter, and now it took me right to the m's. Okay? Or if I wanted to go to the t's, I could press 4, because that has the green T above it, and it brings me right to the t's. So I don't use the catalog super often, because the functions I use, I know where they are. But if I couldn't remember, like I don't know where text color is off the top of my head, no idea. But I could find it in the catalog. Okay, so the catalog is handy if you forget something. Okay, so what does it mean to find f of x? That means to take whatever value that they give you for x, plug it into the formula, and then simplify. So in order to do this, I have to give you two things. One, I have to give you a formula, and two, I've got to give you something to fill in to the formula. Okay, so let's take the formula x squared plus 1. And in the formula x squared plus 1, I'm going to find 3 different things. We're going to find f of negative 2, f of 3, and f of a. So it means we're going to take each one of those one at a time, fill in the value that I ask you to into the formula for x, and simplify as much as you can. Let's start with f of negative 2. So you're going to look at the formula. Everywhere you have a variable, change the variable, in this case, to negative 2. And when I do negative 2 squared plus 1, what will that give me? Yep. 5. Okay, let's check it on the calculator. Let's do negative 2 squared plus 1. Negative 3. It's because I don't have parentheses around. Okay. When you type in a negative number and you square it, if you don't put parentheses around it, what it's going to do is it's going to follow order of operations. Exponents come first, so it's going to raise the 2 to the second power and get 4. And then it's multiplying by a negative in front. Multiplying comes after exponents. So it's really doing 2 squared and then multiplying by negative 1. If you meant to do negative 2 times negative 2, you need to type it in like that. Now it's going to square the negative with the 2, and that's what you were expecting. Okay, so that's another thing with this calculator. Make sure if you're raising a number to a power and it has a negative symbol, put it in parentheses. If there's no negative symbol, then you could just do 9 squared or 9 squared. Well, that doesn't matter. All right, let's do f of 3. Okay, what's my formula going to look like when I substitute in this for x? Yep.
3 squared plus 1.
3 squared plus 1. Notice no negative, so I'm not worried about parentheses on that one. And 3 squared plus 1 will give me 10. And do one more, f of a. What's that formula going to look like when you plug in a? Julie?
A squared plus 1.
Right, a squared plus 1, and there is nothing else that you can do. with that. Yes?
Can I use that?
Yep, just sign out for me. Okay, so any questions on what it means to evaluate? And I think I just had more space down here, which I don't need. Okay, so last one. So I told you earlier that not everything that you can draw is a function. Now, the calculator, if you go and turn the calculator on and you press the mode button, it's the button next to second, right at the top, you'll notice that it says function. This calculator can only draw things that are functions if it's in the mode called function. Right? That means it can't draw anything that's not a function. Okay, this calculator only draws functions. We'll talk about some of the other things it can draw later on. Not right now. So that's an example of one I gave you earlier, and I said this was not a function. Because I said if you plug in, I think I gave you 4. And I said, what's the square root of 4? And someone told me 2 and -2. 2 different answers. That's not a function. Okay. So let me graph that and see what something that is not a function looks like. Now, I just told you earlier I can't really graph things that aren't functions. Well, I can kind of cheat and put 2 different graphs together. Right? So technically, the calculator is still drawing functions. I'm just drawing 2 things that are functions back to back, and together they're not a function. Okay. So that's a function, the blue one by itself. The red one by itself is also a function, but when you put them both together, you get this shape, and that's not a function. And the easy way we can tell something is not a function, if the idea of for every input there's only one output, if that doesn't make sense, you're maybe more visual person. If every input only has one output, then you're going to be able to take a vertical line, put it everywhere, and it would only hit one time. Does that vertical line only hit that picture, including the red and the blue part together? Does it only hit it one time? No. So what that means is this picture fails the vertical line test. When a graph fails the vertical line test, it means you were able to draw a vertical line and it hit the graph more than once. Because it hit more than once, the graph that you drew was not a function. Okay, so just going to look at a couple graphs, and I want you to tell me whether or not they are functions. Okay, and I'm going to draw some things on the calculator right now that you might not know how to draw. That's fine. I just want you to look at what I draw. All right, let's start with this one. Is that a function? Yes, this is a function. Because no matter where you put a vertical line, it will never hit the graph more than once. How about something like, let's do something like this. Let's draw this one. I might have to zoom out a little bit. Let's go -60 and 60. Not quite enough on the negative, but So what I'm trying to do is find a complete graph. I think that'll be fine. How about that one? Is that a function or not a function?
Function.
Yeah, that's a function. That's fine. So function. All right. Let's try something like this. Let's go. I should have gone a little further left than right. But I think you can still see what it is I want you to see here. Okay, how about that one? Is that a function?
Definitely.
No, not a function. Okay, that fails the vertical line test. Okay, because you can draw a vertical line and it hits it more than once. So, not a function. Okay, how about, let's do this one. Function or not a function? Can't even tell. Let me zoom in. Let me zoom in more. We still can't see it. Function or not a function?
Non-functional.
Not a function. Okay, so it's all different kinds of graphs that we can draw. Some are functions, some aren't. And I changed the mode on the calculator to do some of these fancy ones. So we're not even going to worry how I did those right now.
Right.
But I'm just showing you what's a function and what's not a function. Any questions on any of those?
Are we gonna have to do that for this year?
Drawing like spirals and
Yeah.
petaled rose things.
That's cool.
Maybe eventually, yeah.
Oh god.
Yeah, but that's chapter 9. We're in chapter 1. So we got a little ways to go. Any other questions on the vertical line test? Okay. All right, so homework for tonight. We already did page 20 last night. Would be page 30. It's 3 through 8, 11, 13, 16 to 19, and 24. So tomorrow when you come in, we'll go over that, and that's all we're going to do for tomorrow. Just review the homework, and then our first test will be next academic week.